everyone, my name is Shojit Shah. Welcome to our YouTube channel Helm of Science. In the previous class, we discussed two important chapters vigorously come in any competitive exam and as well as boards exam. So that two videos were very important for all of us. Today I will not discuss any PYQ session. Today I am going to discuss a very important chapter. That is not a specific chapter. That is a segment of a chapter which is used actually in everywhere. In carbonic chemistry, in alcohol ether phenol, in our general organic chemistry, in alkane, in everywhere. Fine. So this reaction, today I am not going to tell you that this is a specific chapter of class 11, yes, this is a specific chapter of class 12, but this is a specific segment or this is a specific topic in our organic chemistry. So first question is what is rearrangement? Rearrangement reaction. What is rearrangement reaction? First, discussing the reaction, first highlight this rearrangement term. Forget about chemistry. First, what the thing first come on your mind when you hear rearrangement. Rearrangement means some change in position, rearrange. Suppose we did alphabetic rearrangement. Suppose sum of word is I can say sum of word is missing. So we have to rearrange the word and make a sentence or make a proper word. So in terms of chemistry, rearrangement is like that. We have to for in case of rearrangement, first we have to mainly check the rearrangement should always occur only when the system will stabilize. The system will stabilize. So what do you mean by stabilization system? I have discussed the reaction intermediate, that is carbocation. Suppose carbocation. Mainly in our syllabus we have the carbocation rearrangement. Mainly, most of the cases. Okay. So suppose if I draw this structure, that is A and that is B. Fine. If I tell you which one is more stable, you can easily say that sir, this is a 1 degree carbocation and this is a 2 degree carbocation because this carbon is attached with 2 carbon and 1 hydrogen, and this carbon is attached with 2 hydrogen. So if any carbon attached with 2 hydrogen, that is 1 degree or primary and another is secondary. So we know the secondary has 2 plus I effect as well as 3,3,6 alpha hydrogen. So it becomes more stable. So if we do something, suppose this, forget about this thing. Now try to think that can you go from A to B? There is any way to go from A to B? Yes. Suppose if I write the structure properly according to the bond, okay, fine. Now this is 1 degree carbocation. If this hydrogen, sorry for the interruption. Now suppose this hydrogen will shift to this carbon, then what happens? It will go in that carbon with its electron density. So if this hydrogen will go with its electron density, then the carbon become electron deficient. So if the carbon become electron deficient, now positive charge will come on this carbon. Suppose this is 1, this is number 2. Then what actually, and this CH2 plus become CH3 because the deficiency is over because of shift of hydrogen. Now what actually happened? Here hydrogen is shifting from 1 to 2. So this rearrangement, or this is a shifting or rearrangement of an atom. So this type of rearrangement is known as, and it can written as 1, 2 hydrogen shift. So this is a very important topic. So this reaction is known as 1, 2 hydrogen shift, or not only hydrogen, we will see hydrogen, methyl and phenyl. With three will take part in this shifting. Fine. So this is clear. So what happened? Why the now I am asking that why the rearrangement occur? Because rearrangement only occur when the stability of the species will increase. Without any stability, without no rearrangement. Why someone will rearrangement if someone get no stability? Fine. So in case of chemistry, in case of compound also, the molecules, the compounds, the substrate will try to become stable, more stable. And we know that carbocation, stability of carbocation is a very important phenomenon in case of our organic chemistry. So fine. So this is known as 1, 2, H hydrogen, 1, 2 hydrogen shift. Now I will show you methyl shift as well as phenyl shift. Then I will tell you the migratory act, which one will participate in more powerfully shipment. That means a migratory aptitude. Which one will be faster migrate? Fine. So note it down properly, and I will go example by example. Okay, fine. Write it down. Now this is our second example. Fine. So in this case also we have a 1 degree carbocation. Fine. Okay. Then what happened? Here no hydrogen is present. So methyl will go in the rearrangement reaction. Here methyl is only present. So methyl will go on this carbon 1 and 2 in this carbon. So what will our desired product? CH3. Because of going 1 CH3, this become electron deficient, that means carbocation, and we get CH2 CH. That means a ethyl group. This is known as ethyl group or ET group. Now fine, look at that very carefully. Now this carbon is 2 degree, as well as how many plus I effect? 2 plus I effect of CH3, and 3, 3 6 alpha hydrogen is present there. So this become more stable. So this rearrangement will also occur. If there is benzyl, suppose pH CH2, then what happened? This is known as 1, 2 methyl Me shift, and here 1, 2 pH shift. So after the pH shift, what happened? pH positive, CH2 pH. Okay, fine. Look at very carefully. This carbon is now 2 degree. This carbon is now 2 degree, as well as this is a benzylic carbocation. I have teach you very briefly about benzylic carbocation, and I have shown you that why the benzylic carbocation is so much stable. The benzylic carbocation is stable due to the 2 phenyl ring participate in resonance with this carbocation. These 2 phenyl ring participating in the resonance with this carbocation. So this is a benzylic carbocation. Fine. So this rearrangement will occur very vigorously. So there are 3 types. I show 3 types. There are 3 types of rearrangement. First one is 1, 2 hydrogen shift. Second one is 1, 2 methyl shift, and third one is 1, 2 phenyl shift. Now the problem will arise when there is competition between them. Suppose I will, okay fine, write it down properly. Why rearrangement occur, understand properly. Then I will show the competition when hydrogen, phenyl and methyl is present in a one atom. Then which one will go to the migration? Okay, fine. First write it down. Very sorry for one thing, that these carbocations, this and this and this carbocation both are 3 degree carbocation. Very sorry about that, I just forgot about this carbon. Now I will explain exactly the wrong concept. If any carbon is attached with 3 carbon, then it is become 3 degree. So it is benzylic obviously, and as well as when the carbocation is attached with 3 carbon, then it become a 3 degree carbocation. Okay, fine. And here also we have this carbocation is attached with 3 carbon, so this is also 3 degree carbocation. And now one thing, it has how many alpha position? 1 and 1, 3 alpha position. So total number of alpha hydrogen is 3 plus 2, that means 8 alpha hydrogen is there. That's very sorry for the misconnection, that these 2 carbon, first one is first rearrangement is going for 1 degree to 2 degree carbocation, but in this case it will produce 3 degree and 3 degree, and in this case as well as 3 degree we will get a benzylic carbocation. So correct the wrong part and write it down as a 3 degree. And now I am going to show the competition reaction. Okay, fine, write it down. Now look at very carefully. This is a 1 degree carbocation because it attached with 2 hydrogen and 1 carbon. Fine. Now this one position have 2 CH3 group and 1 H group. So there is 2 possibilities. First possibility is shift of hydrogen. Now if hydrogen will shift, then what happen? This carbocation will form. This carbocation will form, and if the CH3 will go, then what happened? This carbocation will form. Now look at very carefully. Which one is more stable? We have to check. Now look at very carefully. This is careful, huh? This is 3 degree carbocation. This is 3 degree carbocation, and this is how many? This carbon is attached with 2 carbon, so this is a 2 degree carbocation, and this has a 9 alpha hydrogen. Look at very carefully. 1 alpha position, 1 alpha position, 1 alpha position. Both have 3 hydrogen, so total is 9 alpha hydrogen. So carbocation is stabilized by 3 plus I effect and 9 alpha hydrogen. So which shift, this or this? 1,3 hydride shift or 1,2 methyl shift? Which one is favorable? You can see easily that 1, 2, H give more stability. So here in this case hydrogen will migrate, or I can say the migratory aptitude of hydrogen will more than CH3, and actually the order of migration is hydrogen, that is H minus, then pH minus, then methyl minus. This is actually migratory aptitude. This is the migratory aptitude. Fine. This is the migratory aptitude. Okay. So now I am going to show 2 examples how the migratory aptitude will occur in competition reaction. Then I will go up to the next rearrangement reaction. Fine. Write it down properly. Okay, now fine. Look at very carefully in this reaction. What happened? This is 1 degree carbocation. Fine. This is 1 degree carbocation. Why this is 1 degree? This is attached with only 1 carbon and 2 hydrogen. First, what happened is in this H2, I can write like this way, H2. Fine. Now in first step, 1 to hydride shift will occur. 1, 2 hydride shift will occur. Then what will be our product? CH3 CH plus CH3. Now become this carbocation is 2 degree carbocation because it is attached with 2 carbon. Fine. Now the question is that is this reaction will stop? Will the reaction stop or occur again? Will the reaction stop or occur again? Look at very carefully. This hydrogen I can write like this way. Fine. If this hydrogen will shift here, then what happens? Look at very carefully. This is a main key of the rearrangement reaction. This is a key factors actually. Now this CH3 plus CH3. Fine. Then here what happens? CH2 CH. Okay. Now look at very carefully. This carbocation is attached with three carbon. Yes. So this is 3-degree carbocation. So here also 1,2 might write H minus shift. Fine. So what happened? Look at very carefully. 1,2 hydrogen shift will not stop at 1 step or 2 step or 3 step. It will go furthermore until the carbocation or the species will get high stability. Again I repeating myself, the carbocation rearrangement or this type of shift reaction will occur until the species will get the maximum stability. Fine. So in this case, that is why in this case 2-step hydride shift will occur. There is no chance of further rearrangement is possible. I am showing you an example. I will show you any further example where more than 2 hydra shift reaction will occur. But first understand that rearrangement will occur until again I repeating myself, rearrangement occur until the system get maximum stability. Fine, write it down properly and I am going to show the further example of this type of reaction. Now look at this example. This is a very important example because an exception will occur. Exception. Organic means a lot of exceptions. Okay. Now fine. First thing is very clear. This is 1, this is 2. 1 hydrogen will shift. We did it lot. This type of reaction. 1, 2 hydration. Then what happens? CH3, CH, PH, CH, CH3. So right, CH plus and CH3. Here carbocation will form. Now this is 1 degree. That was 1 degree. Now this is 2 degree. Is there any chance of further stability? Yes. If this hydrogen will shift in this position, it is also 1, 2 methyl shift. Then what happens? CH, PH, C plus CH3, CH2, CH3. Now this is 3 degree. Okay. Now you can ask me, sir, that is, and you can say also that is a 3 degree carbocation. So what is the are there any chance for any extra rearrangement reaction? I will say yes. Look at very carefully. If we think, look at very carefully. Okay, this is a 3 degree carbocation. There is no doubt about this. There, if any carbocation will occur, then what happened? There is a 3 things will occur. Okay, just a second. Okay, there is 3 things here. 1 CH3, 1 pH and 1 H. So what was our migratory aptitude? H minus, then pH minus, then methyl minus. Fine. Now, what group will migrate? This hydrogen, because migratory aptitude. Sorry, now this is become carbocation. CH, CH2, CH. Now look at very carefully. This is 3 degree carbocation as well as this one. This is also 3 degree carbocation. This is also 3 degree carbocation. But this is also benzylic carbocation. Also benzylic carbocation. Fine. Because of gaining extra stability by the benzylic position, this migration will occur further. Okay, that is 3 degree, that is 3 degree. So what is the necessity of this migration? Because if the migration will occur, then 3 degree carbocation as well as benzylic carbocation will form. This is a very important reaction. We think that this becomes 3 degree and reaction stop here, but the reaction will go a further step. So this is our total rearrangement product. Now the next example, I think this will be the last example of the class, and next day I will go to, next class I will discuss further 1-2 example, but understand the class is very thoroughly because this is the most important one. Fine. Now next problem will a bit interesting problem. Okay, note it down properly. So this is our next example. It is written as like this way. This is a bond line notation. Bond line notation. Fine. I have taught you everything about this notation. Okay, fine. Now this is a carbocation. Now what happened? There is a 2 hydrogen is present. After the rearrangement, 1, 2 hydride shift. What happened? This carbocation will form. Now look at very carefully. If I write it properly, this is CH, this is CH2, and again this is the 3-member cyclopropane ring. This is known as cyclopropane. Fine. This is a NEET or JEE level question. Okay, fine. This is like this way. Now look at very carefully. This is a 2 degree carbocation. Okay, and what is the type of carbocation is this? CH2, CH2, CH plus. This is also 2 degree carbocation. Okay, so you can ask, what is the necessity of this rearrangement? What is the necessity of rearrangement? Think and listen very carefully. I have taught you this. If carbocation is prepared, in front of the cyclopropane ring, that means this carbocation is prepared, and this is the most stable carbocation. This is the most stable carbocation, and this is the most stable carbocation. This is the more stable than benzylic carbocation. If I compare with this benzylic carbocation, BH2 plus, okay, this will become more stable because there is a, I have taught you, this is a banana bond occur. This is a banana bond. Electron donation like this way. Electron donate like this way. This is why this is a carbocation is more stable. That is why this rearrangement will occur. Fine. Write it down properly. Okay. Fine. So this is enough for today's class. Fine. This is our homework problem. First is reagent is silver nitrate, then water. I will give you a hint. Silver nitrate is a reagent which eliminate a halogen group. This is a Cl, which eliminates the halogen group and form a carbocation. Okay. So this AgNO3 will form a carbocation in this position. Now I will not help you. Now after the carbocation rearrangement, water addition will occur. So think very carefully, properly, and do it as your homework. So let's finish it. This is today enough for today. Thank you for watching and keep practicing. Okay, fine.